So hello everyone, welcome back to another video, and today in this video we are going to discuss the problem maximum nesting depth of the parentheses. So this is a Leetcode easy question. So given a valid parentheses string, return the nesting depth of S. The nesting depth is the maximum number of nesting parentheses. So let's deep dive into the question. So let's discuss the example test case. Let's first understand like what is maximum nesting depth. It is a maximum number of opening parentheses which are not paired. Let's understand. For example, let's take, so this is first, this is second. So these are two parentheses which are not paired yet. So for now, we can say like maximum is 2 for now. Now this is 1, this is 2. Now this is paired. This is now no more considered. Let's jump here. 2, 1, 2, 3. So now maximum is 3. Now this is paired, not considered. This is paired, not considered. This is paired, not considered. So maximum is 3. Maximum is 3. So this 3 is the answer. This is the maximum nesting depth. Similarly, let's take another test case. 1. Like, let's start from the first. 1. This is paired, finish. Again, 1, 2. Maximum is 2. This is paired, finish. 1, 2, 3. So maximum is 3. This is paired finish, this is paired finish, this is paired finish. So answer is 3, right? So what we can understand, number of opening parentheses which are not paired. Like we can understand in any way, but in easy language, like I can think like number of opening parentheses which are not yet paired. So for example, these three are which are not yet paired, but after they get paired, it become 2. Now it become 1 because only 1 is left. Now 0 are left, so 0. So at max, answer is 3, right? So this is the idea. Now we will discuss the two approaches. So the first approach will be using stack. Now the question is why stack? Why not other structure? Stack because whenever we want to complete the pairs kind of thing. For example, this is a stack. It takes opening parentheses, then closing parentheses came. For example, let's take it again. So opening, closing parentheses came. So we can see like this is completing the pair. So in such kind of thing, we generally use tag. If you have seen the previous videos as well of strings, so there you can get the more intuition like why we are using tag. So it's a simple thing. When we want to complete a pairs kind of thing, so like we want to keep the track of parentheses, right? So in that case, we use a stack. So let's jump to the approach one using the stack. Now, how we will use a stack? Now in the stack, now what we want the maximum number of opening parentheses which are not yet paired. So in the stack, we are keeping track of number of opening parentheses, right? So let's understand, let's create a stack first, then we will get the better clarity over it. So opening parentheses came, push it. 1, skip. Now opening parentheses came, push it. 2, like just keep these all things. Like they doesn't matter to us. We are just thinking about the parentheses only, right? Now, there is a closing parenthesis scheme. Now, at this time, you can see maximum stack size is 2. That means 2 opening parentheses are present with us. So let's update the maximum variable as 2. Like we will update it every time. But let's, for example, at first we got the 1, then becomes a 2, maximum answer 2, right? Now, when we got this closing parentheses, we will just remove it from the stack as well. Like this pair has been completed. Don't think about it. Now, similarly, we will come here, push it. We will come here, push it. Like every time we are updating the answer size, like stack size. So it is the 3. Maximum stack size is 3 now. Now again closing come. This pair is completed, remove it. Again closing come. This pair is come, remove it. Again closing come. This is completed, right? So the maximum answer is 3. So this is the approach using stack. This is very simple. Just we need to take the answer is equal to maximum of answer comma stack dot size. Like every time just whatever is the stack size, just update it in the answer. So what is the time complexity for this? Time complexity is big O of n because we are iterating. over the complete string. What is the space complexity? Big of n only, because we are using the stack, right? So stack will keep track of at most maximum n characters if all are opening parentheses, right? So let's jump to the code for this approach one. So here is a stack initially, and here is the answer variable, which is initially 0. Now we want to traverse the string. Let's traverse the string. Whenever we find the opening parentheses, what we will do, just push the character, like push the index or the character, because it doesn't matter. We want just the size of stack, like what is the maximum number of opening parentheses which are not yet paired, right? So else we will just say if s of I is closing, just pop it out, right? Now at any point we just want the stack size. What is the stack size? And we want to just update the answer variable like maximum stack size, and we want to just return the answer. So let's try to run the code and check whether it's working fine. Yes. So let's submit the code. Yes, it's totally working fine. So let's jump to the approach 2. Let's understand, then we'll just come to the coding part of that. So in the approach 2, we are going to use the counter thing. We have used in previous videos as well. So using the counter. So there are the two, like we don't need the stack because we are just trying to maintain the stack size. For that, we're using stack. Why? We can use without stack. Like we can calculate it without stack. How? Let's understand. We are going to maintain simply, it's like answer variable only. Just created the maxi. You can create anything. And this is the count variable, which is keeping track of number of opening parentheses that are not yet paired. Let's understand like how we will do. So let's get the intuition from the approach when only using stack, like how this approach can help us. Let's understand like how the counter, how we are doing just using the count variable only. So when we understood the approach one, we are just pushing the opening parentheses, and after we are getting the closing parentheses, we are just going to remove it, right? So it's just like what we are doing. Count was initially 0. When we get opening parentheses, became 1. When we again get it become 2. When we get closing parentheses, just we are subtracting it. Size became 1, right? Stack size became 1. So this is the intuition. Like if I repeat again, what we are doing when we are adding the like opening parentheses, what we are just doing, we are just incrementing the count variable, stack size or the count variable. But whenever we are getting closing parentheses, we are just completing it. So in that case, we are just reducing the variable, stack size or the count variable, right? So in this way, we can understand that the simple thing is what we need to do. Instead of using stack, there is no use of stack. We just need the count variable. Increment count whenever we get opening parentheses, decrement count whenever we get closing parentheses. Take the maximum every time of the count variable, you will get the answer. Why we are taking maximum count? This is similar to doing the maximum of stack size only, right? So this is the intuition behind this. So let's dry run this first so that we can better understand like what it's happening. So we got the opening parentheses, increment the count variable and take the maximum. 1 plus skip it, opening parentheses, increment the count variable, find out the maximum. 2, 3, skip it. Now closing parentheses, decrement the count variable. It's like we are popping out from stack. Decrement the stack size. Take the maximum variable, it's still 2. Again, opening parentheses, increment, take the maximum, still 2. Take the like incremented stack size, it's similar to like as we are just incrementing the count only. Maximum become 3. Now closing, popping out from stack 2, closing, popping out from stack 1, popping out from stack 0, maximum is 3, and that is the answer. So it's simple. It's just like we are using stack only. Popping out, pushing in is incrementing, popping out is decrementing. Now what is the time complexity? Time complexity is big O of n only because we are just iterating. And what is the space complexity? Big O of 1, constant, because we are just using two variable. We are not using stack now. So this was the approach 2. Let's jump to the code of approach 2. So let's jump to the code of approach 2. So we are maintaining a count variable like stack size and maximum, right? Now we are going to traverse the string and we will ask if s of I is opening bracket count plus plus, if s of I is closing bracket count minus minus, and every time just take the maximum of count and just return the maximum. So let's try to run the code and check whether it's working fine. Yes, let's submit the code. Yes, it's totally working fine. So this was all about this question. If you like the video, please like, share, and subscribe to my channel. Thank you and have a nice day.